Welcome back to the channel. We are going to do an exercise which is really interesting, which determines if two strings or two words are isomorphic. So when are two strings isomorphic? If all the characters in S can be replaced to get T. So you have, in this scenario, you have egg and add. So let's do like this, egg and add. So when you take literally every single letter and you map, say you map E to A, then you map G to D, and here G is already mapped to D, so these two strings are isomorphic. If you have a different scenario, foo and bar, which is example 2, the reason the output is false is because if you map F and B together, then you map O and A together, you cannot map O to R because you have already a mapping of O to A. So these two strings are not isomorphic. So how do we do this? Let's go back to our example and add. We can use a dictionary and we can store each character. So if we have like a map of char to char, right? Since C#, this would be like a dictionary. So then you would map E. So you need to iterate the words, right? So you go like this. This would be the algorithm. So you go like, okay, I'm gonna map E to A. These are the letters at index 0 in both strings. And then you ask yourself, does this pair exist already in the dictionary? No, because we just initialized it. So it's okay to add. Next. So now you are here. You map G and D. Does this exist in the dictionary? No. It's okay to add. So now the iteration has reached position 2. So you map G to D. Does this pair exist already in the dictionary? Yes. So we just skip. So because during this algorithm we have not broken the property of isomorphism, that means we can just return true from our method. Let's take another example. We initialize the same map of character to character. And this time we take the words foo and bar. So let's take the first iteration. We are at position 0. We evaluate F and B in both strings. F and B. Does this pair exist in the map? No. It's okay to add. Second iteration. We are at O and A. Does this pair exist in the dictionary? No. It's okay to add. Third iteration. We are at O and R. O and R. Does this pair exist in the dictionary? Well, it does not. However, O was already mapped previously. And what that means is that this, first of all, you cannot add in a C# dictionary the same key twice. And second of all, this breaks the isomorphism property. So these two here will return false, not isomorphic, right? So let's see, how do we do this? Let's delete all this. Let's actually do this. So in C#, this is a dictionary. Let's say, I don't know, groups or something. So then we do exactly what we did earlier. We know that the strings are always going to be the same length because this is a condition. This is one of the constraints. t dot length is always going to be the same as s dot length. So we don't have that, we don't have to worry. First of all, if t dot length does not equal s dot length, then by default the strings are not isomorphic. So we don't even need to calculate anything. But since they are the same length, we need to go and look at every character. So this is what we're going to do right now. We're going to look at every character. We just take the length of either one because it's the same. So now basically, check 1. Does the current combination of letters in the current iteration exist already in the dictionary? If not, then let's add it. Is there any element in groups already which has, so if there are no groups with this combination already, just add it. The second check we have to make is the invalidation of the isomorphism property, which means exactly what we were speaking about before. If we have foo and bar, if we map O with A, we cannot remap O with R. So we need to search in the dictionary. Do you already have a mapping where the first character maps and the second character doesn't map, or vice versa? If yes, return false. If groups has any element.key maps to S and that value does not map to T, or element.key, or the other way around. If this scenario exists, then we need to return false, because then the current iteration means the strings are not isomorphic. I think we should actually make this check as the first check. And then if this passes, right? If this passes, then we add it in the dictionary. So I have reversed this check so that first of all we check if the property is invalidated. If everything was fine in the first check, then we just verify if it's in the dictionary. If it's not, we just add it. If everything was fine, we return true. Let's see how this works. Oops. This is a lambda here. Okay, it passes with egg and add. What about the negative case? Foo and bar. You cannot have two mappings of O to different letters, right? So it's false. It cannot be accepted. You can have two mappings of O if you have the same letter. So this is true now. Thank you, and see you next time in the next Leetcode exercise. Ciao.